All right, folks, it's Bass Action back in action here. In this video, we are going to talk about the midpoint formula, really only very much in passing there, and then we're going to do a compare and contrast of the Pythagorean theorem, the distance formula, and the equation of the circle. The first big idea that I want you to maybe jot down is that these three formulas are actually all the same formula, just slightly rearranged or presented differently. All right, let's jump into this. First things first. The midpoint formula, although I'm not going to do a lot of examples of that here, the midpoint formula is just an average, okay? That's our really big thing that we want to remember with this, is that the midpoint is just the average. So when you're asked to find a midpoint, you're just averaging two values. Now, the next one that we're going to look at, this is going to get into our three examples here, will be the Pythagorean theorem. So our Pythagorean theorem, we're pretty familiar with this. Our c squared equals a squared plus b squared. It is important to remember that the c squared does need to be for the hypotenuse. Now, you'll notice that my picture here is not actually labeled as a right triangle. It should be, so we can actually fill in this right angle there because it should actually be a right angle there. So we're going to have our hypotenuse, that'll be c. Our a and our b are interchangeable, those are our legs. So we could go ahead and do this very quickly. So we'll have our hypotenuse squared, our x squared, plus our 3 squared. You could do that in your head right off the bat if you want. We should not need a calculator for really anything that we're going to do on this page. If we're squaring this radical, we're going to square the 2 and we're going to square the radical. So that's going to be 4 times 3. That'll give us a 12 on the left. X squared plus 9. Let's subtract that. That's going to get us a 3 equals x squared. So our x is only going to be the square root of 3. We don't need to worry about the plus or minus that would happen here because, of course, the side of the triangle can't be negative. Now, if we want to move from our triangle that's drawn in to our distance formula, all that really happens here is this turns into a bunch of variables. So I can turn this into a little triangle here by actually dashing in those legs. So if we wanted to give a representation for this leg in the triangle, I could now write this as an x sub 1 minus x sub 2, and the other leg would be y sub 1 minus y sub 2. We could have subtracted those in the other order, it wouldn't have mattered. And then our distance between these 2 points we would call d. So we've really just turned this into a triangle like we just did, which means our distance formula would be our d squared, that used to be the c squared on the last example, and then we're going to square each leg. So x1 minus x sub 2, that's going to get squared. We're going to add that just like we did with the legs on the Pythagorean theorem in the last problem. Y sub 1 minus y sub 2, we're going to square that too. And then if we wanted to actually write this as the distance, we would just take the square root of each side. So that is our distance formula. Let me finish writing this off. So if you find yourself forgetting the distance formula, just remember the distance formula is really just a Pythagorean theorem, but we have to calculate these legs instead. Now, the equation for a circle, this was probably only done very, very small in passing in your geometry days, so you haven't looked at it in a really long time, so truthfully, you've probably forgotten. All we need to do for a circle, our circle is this set of points that are equidistant from our center. So we need an equation that's going to give us this set of points, and we need to know this radius. This is what's going to change our different circles. So our radius is now going to be our r. That's the distance between those 2 points. And if we set this up just like we did back here for our distance formula, we're going to set this up for our r squared. We'll say r squared. And now we're going to calculate our distance. So our distance between our x and our h is the x coordinate of the center. Our x is a point on the circle. Now, we could technically do this subtraction in either order, but mathematically it's usually written as an x minus the h and then we square it. So notice that this piece is the same as this piece, which was really our 3 from the very beginning. And then we're going to add that, and we're going to say y minus k and squared. And this piece is the same as this piece, which was where our x was in the beginning. So this is the equation for our circle. What we want to recognize is that this left side is the radius squared, and then the h and the k, this will be the center of the circle. This is what we're really going to focus on for the rest of this video. All right, now let's take a look at how we can apply all that. So we want to write the equation for a circle in standard form. That means the one that we did up here in the previous example. And this time we're given the endpoints of the diameter. This is where I'm going to use my midpoint, okay? If we want to find the center of our circle, we need to find the midpoint. So that's going to be our very first thing that we will do, is we'll find our center. This is going to be our midpoint. And that's where I was saying it's the average. So we're going to average these two. So we would really say 6 plus a negative 2 or 6 minus 2. Then we divide by 2. And then we'll have our 1 minus our 3. And we'll divide by 2. That's going to give us a center of 2, negative 1. This will become our HK in the equation that we just developed. So if we wanted to even start that, we could start that down here. We could start writing that equation, and we would say x minus 2, and then that gets squared. And then we're going to add to that our y minus our negative 1, so that'll become y plus 1, and we're going to square that. Now, what we still don't know is the radius of this circle. So I'm going to have this, just leave this as an equals, and now we need to calculate our radius. To calculate our radius, we have two choices. You could calculate the length of the diameter and divide by 2, or we can use, and the numbers are going to be a little smaller if we do it this way, we can use our center and one of our points. I'm going to use this one, and if we use our center and one of the points on the circle, that will give us our radius, and that's just going to make our numbers maybe a little smaller. So our radius, I'm even going to calculate this first as a radius squared. I'll have a negative 2 minus 2 squared plus 1 plus 1 squared. So we've got an r squared. This is going to give us a 16 because our negative 2 minus our negative 2 is negative 4. And when I square that, it's positive. 1 plus 1 is 2. Square that, it gets me to a 4. So my radius squared is 20. So my radius is a square root of 20. I should be able to simplify that radical quickly and get me to a 2 square root of 5. Again, I should not need a calculator for any of this. That means that this 20 right here, because it's the radius squared, this is what's going to go right here to finish the equation for our circle. Now, the other questions that we do want to answer here, the length of our radius is not the square, or is not 20, it is our 2 square root of 5, and then I can double that answer for my diameter of 4 square root of 5. Now the last thing, or another thing that we want to be able to do, this not our last, is we want to write the equation for our circle, and when we say this as a function of x, what this is really asking us to do on this problem is to get the equation for a semicircle. All that means is that we are going to take this equation and we are going to solve for y. So that means I'll have y plus 1 squared, and then 20 minus this entire quantity. Then I'm going to take this square root of each side. Gives me y plus 1, and now I have a plus or minus on the right-hand side. And the last thing I need to do is to subtract the 1 from the other side. So my equation is y equals negative 1 plus or minus the square root of 20 minus x minus 2 squared. This is the equation of our semicircle. So separately, this would give me the top half of a circle. This would give me the bottom half. You could even type this into Desmos and see those two pieces. The last thing that we're going to do related to our circles, just more algebra, we are going to take this equation that we just worked with right here, and now we're going to find our y-intercepts. That means that we are going to let x equal 0. So now I'm going to have y equals -1 plus or minus 20 minus, now this part I'm going to do in my head. If x is 0, that leaves me with my -2 here, and I'm going to square that, so I really have 20 minus 4. This gives me a -1 plus or minus the square root of 16, -1 plus or minus 4. So that means I have -1 plus 4, that's a 3. -1 minus 4 is a -5. And if I want to write those as correct intercepts, they would look like this. I would write these as their ordered pairs. X was 0, and we calculated those y values. So that is everything that we will want to be able to do with our circles for right now. We'll add in one more thing in class, but this is the heart of it.